Hello and welcome to another exciting Breakfast with Unity. I'm your host Max Moreau. Today we're going to be doing some more shader work. This time we're going to be showing how to blend a texture with itself to kind of help mask tiling for textures that you have to have on like long, large areas, like on terrain or on planes or whatever. So, first of all, this tutorial, we're going to be following some stuff that's in another tutorial that's actually for Unreal. And they actually have some really good documentation in their stuff here. I definitely recommend people check it out, and check out Unreal too. Honestly, I prefer Unity myself, but that's just a personal preference. Like, I believe that there's a lot of great tools out there today, and most of them are really cheap, and so definitely give it a shot. But basically, their technique here is they take a texture where you can see the tiling really easily. And, well, not really easily. I mean, this is still a good texture. It's a seamless tile, but you can still see the repetition. And they reblend it with the same texture at a different texture coordinate rate, and also flip it around, and you get something that looks more like this. And this works really well for natural textures. They mentioned that this is more for natural, smoother domain textures. If you have really hard edges and stuff, it will not look quite as nice. So, but we're going to give it a shot today on the show in Unity's shading language. Well, in C... What are we using? We're using CG, but also Unity's like meta language for the properties and stuff. So, what we're going to need first is we're going to need a texture to tile. So I just searched for tile and grass, and I found this free seamless green grass textures. It is CC's by attribution unported. I'm just going to put this link in, and then also say goodtextures.com somewhere, because they didn't have specifically what they wanted to say here. So I already downloaded this, I think. Thought I did. Yeah, I did. I'm just going to open this up. I'm going to put this into here. These must be big old textures. That's cool. And hopefully these will be easy enough to see the tiles. I used the texture last night in my experimentation that unfortunately I couldn't find a license for. It looked like it was free, but I don't want to trust it. I don't trust it. I want to get rid of these spaces here to be consistent with everything else. So first of all, where did the green grass textures go? I'm going to put this under third party licensed. And we're going to put a text here. Reveal and Finder, text edit. Remember, always reference your sources and stuff. So, especially, yeah. Green grass textures. I'm just going to paste green grass textures found here. Link to the goodtextures.com. I'm going to say made by goodtextures.com, licensed under CC 3.0 unported. Green grass textures, and we will put it... Actually, let's put one layer above that. There we go. So, green grass texture. So let's create a scene that has this stuff in it. Let's create a 3-object plane. We're going to set it at 0, 0, 0. We're going to drag in a character controller so that we can drive around the scene. First person controller. I'm going to get rid of the main camera because the first person controller has a camera in it. I'm going to put the first person controller at 0, 0, and 3 will be fine. I'm going to make the plane considerably larger. 10, whoops. And we're going to create a light, and we're going to go ahead and create a material for this. So we're going to go create new material. We're going to call this diffuse standard tiling, and we're going to put our green gas texture on here, and we're going to apply it to our ground. Alright, so right now it looks fine, but we're going to increase the tiling considerably. Let's make it 50 by 50. So now we can see there's a lot of repetition in the tiling. So you can see very clearly that you have lines kind of going out into the horizon. It's very easy to tell that it's a tiled texture. But it's still a good texture. I mean, it is seamless, but the human eyes are good at pattern recognition, and we see a pattern here. So what we're going to do is we're going to now blend this with itself by following this node graph and building this out inside of a shader, which I'm going to walk you through here. So so what we're going to do here is, so first of all, how to read this node graph. This is actually read right to left. It looks like it's read left to right because we're just so used to reading left to right, but it's actually read right to left. This is the final color of the object. This is the diffuse component. In our case, it's going to be called the albedo component in the shader, but it's the same thing. The process here is, this is the original texture here. This is the original texture here. There's the texture sample. We take the normal texture, we brighten it, we multiply, and then we multiply it with the same texture but with a different UV coordinates. We brighten it, we desaturate it, and then we multiply it in. The brightness, desaturation, and the brightness and desaturation are intended to be adjustable. And I also like to make the texture coordinate stuff adjustable so you can see what's happening easier. So that's what we're going to be doing. So we're going to create a shader. We're going to call this, I'm going to call it tiling shader. Actually, I'm going to call it improved tiling shader. And actually, that's not what I'm going to create. I'm going to delete this one. We're going to actually go into our built-in shaders. Remember, you can find these just by searching for Unity built-in shaders. These are the source codes for the shader. Unity provides them, but they aren't included in your download when you download Unity for whatever reason. So we're going to grab normal diffuse and work off this as a base. Actually, I probably didn't need to. Whoops. I probably could have just created a new one because I think normal diffuse is actually what it creates for you, but I don't trust it. So we're going to duplicate it. We're going to move it over here to normal diffuse, because if I didn't duplicate it, I'd be very confused later when I tried looking for it. And we're going to call this now improved tiling shader. All right. Now we get to the meat of this program. So so what we're going to be doing is, we only need the surface shader. We're not doing vertex stuff, so we don't need to change that declaration or anything. And what we're going to be doing is, this is the pass for a basic texture. We get the input structure. This contains our UV coordinates. We've got our main texture, which is a variable that we pass in. And we've got our color component. And what this does is this tints it with the color by multiplying the color in, and it just sets the albedo. I'm going to leave the colorizing component out in our version of this script, though you could always bring it back if you wanted to. You just basically multiply color in at some point. We might bring it back in a second here. But so what we're going to need to do is we're going to need 2 of these. This represents our colors based on our different textures. I'm going to call them C1 and C2. We're going to need 3 variables, right? So we need brightness, desaturation, and scaling. So I'm going to go ahead and go to our Perlin example here so I can grab, well, they're all floats. We'll just define them as floats for right now. Actually, we can do ranges. That's what we'll do. I'm going to grab this as an example because I still haven't memorized this format. We're going to have what is this one called? We're going to call this UV scale. Let's see. What should I call this? UV scale, and we'll call this second layer scale. And I'm going to actually range this. This is going to sound like strange values at first, but I'm going to range it from -1 to -16. And this is actually a valid range, and it will actually, I was surprised, the editor will actually parse this correctly, and will have -1 on the left and -16 on the right, so that's awesome. Since it doesn't show the values, the person is not going to confuse them. The reason we do this is it saves us having to do a multiply so that we can flip the texture around, because it's already in there inherently. So we're going to default this to, I liked -7 as a default. They suggest 4 or -4 in the documentation, but I think that having an odd number actually works better, and I found it better at a higher rate. We'll see how it actually works on this texture. So UV scale, we're going to have desaturation, and this will be the second layer desaturation percentage. And this one will be a range between 0 and 1. And it will be defaulted to 0.25. And then finally we're going to do, what's the other one? Brightness. Final brightness adjustment. And we'll do range. I'm going to do 0 to 4. It's probably an excessive range, but it does work. And we'll default it to 2. And actually, I want the range to be 1 to 4. 0 would be a bad brightness to take. Because this process generally darkens things, multiplied usually darkens things. So what we're going to do, actually we can keep the color here, it doesn't matter, it's already in our terms. So maybe, okay, so actually yes, let's just put it in there, it's fine, it'll be fine. What are we going to do? So this one we're going to divide this by our UV scale. So this changes the scale of C2 to be different. And then what we need to do is we need to actually combine all this stuff together. So we adjust the brightness. We adjust the brightness first because it's actually the first thing that happens in either case. So you see the brighten amount here and the texture sample here. This has already been done. We did that right here when we divided by UV scale. So this slot is done. We're calling C2, this we're calling C1. So the next thing we need to do is brightness. So we're going to do C1 times equals brightness. And C2 times equals brightness. And actually, we could put these on the lines above, and I'm going to go ahead and do that. We'll just do times color times brightness times color times brightness. So there we go. So now we've done these nodes here. So we've taken the coordinates, we've multiplied the brightness in. So that's just a multiply operation there. So we're multiplying the brightness in on both sides. Now we're going to do desaturation. Desaturation is interesting. So unity desaturation. I knew there was something I missed. Desaturation grayscale scaler for iOS. So there's a nifty little trick you can do to desaturate things. So you could just slide all of the values down evenly, but that's not actually how we perceive color. We have different luminance values for red, green, and blue, and so this is actually built into Unity. There's a luminance value, so you can give it a vector here, and it will return the completely desaturated version. So what we can do is so this represents 100% desaturation. When you desaturate a picture completely, it means that you'll only see grayscale. There will be no color information in the picture anymore. And so what we're going to do is, to get this value, we do luminance C2, and this should provide us with a black and white version of that color. Now, the thing here is we want to actually have a percentage that this is applied. And so the way we do that is we do a lerp. And what we're going to lerp between is we're going to lerp between C2 and I think we have to do these. Okay, so we want this to be desaturation. So we want the higher this is, the more towards the desaturated version. So yeah, we want C2, comma, luminance C2, comma, desaturation. So this is the amount between that you're going. These are the two values you're interpolating between. So this is the term. This is right here on the texture. Sorry, right here on the texture, the desaturation portion. So that gives us our desaturation percentage, and then we finally multiply these two things together. So it would be C1 times lerp luminance desaturation. And we can just put this directly into the albedo. I think this will work. And I'm not even going to, I don't know why they even set the alpha value there, quite frankly, because this is a diffuse shader. It doesn't even use it. So I'm just going to remove that. So hopefully we got this on the first shot. We may not have. Oh, we already have syntax errors, of course. So, oh yes, we got a few. Parse error at line 6. I messed something up. Second layer. That's okay. That's okay. Oh, there's a semicolon. We actually don't want the semicolons here. Alright, and then we have undefined variables. And the reason they're undefined is we define them here, but we need to redefine them here. So we're going to just duplicate these. And actually, I'm going to just do fixed for. We don't want fixed for in this case. I think we just want I'm just using floats. Float, and float. You might be able to use halves. I'm not sure what the difference in the resolution there is, but it probably would be safe. But I'm just going to use floats for now. So desaturation and brightness. Save. All right. So what we're going to do now is I'm just going to attempt to change the shader to, oh, whoops, we didn't actually name the shader. That's really important. We're going to rename this to diffuse improved tiling. Save. So now when we go to standard tiling, we go down to this thing, and it should say diffuse improved tiling. We hit it, and it looks like it may have worked. So these are slider values so that you can actually adjust things on a per texture basis, because multiply sometimes has some unexpected results. But what we're going to do is I'm going to hit play so that we can get a good view of this. And we're just going to pause it. And so first, let's just compare between the two. If we do diffuse, we get this very obvious tiling, and if we do our improved tiling, much less noticeable. We still get a lot of detail because we're mixing the two maps together. But yeah, it really helps mask that tiling, and it looks pretty good. Now, we can adjust things, and we can do them on the fly, which is awesome. So we can actually make this so that the second layer scale, we can change it, and you can see how it's blending with the first. So like, if we set it all the way down to 0, it's all we're doing is flipping it at this point, and that still helps. We can see that if we switch to diffuse here, that we already get a big bonus just by flipping the texture and reapplying it to itself. But then we can additionally adjust the scale, and that helps remove the repetition because you're blending it with something that repeats at a different rate. We can adjust the desaturation to make it so that you don't oversaturate the colors, and you can adjust the final brightness amount to change the amount that because you lose some brightness generally in the multiply, as I said. So this is our shader, and it looks like it's working. That's awesome. It doesn't require an extra texture or anything. It just requires a few extra operations. Now, you might ask, why would you do this versus doing it in the texture itself? Like you could do the same technique on the texture, right? You could take it, you could scale it, and you could apply it there. Well, one of the limitations on that is you would have to do it at a multiple, because otherwise you won't be seamless on the sides. So if you did like a multiple of 4, your texture is going to have to be 4 times as large to actually maintain the detail that you want. So all of a sudden it's like, wait, that's the equivalent of having 4 textures as opposed to 1 texture as far as memory is concerned. So you've already saved something there. Additionally, this allows us to do scaling that is not at a regular whole interval, which if you were to do that in an actual texture, you would have to find the lowest common denominator, which would multiply your size even more than 4. I don't have the math in front of me right now, but you'll have to take my word for it. I'm going to do one more adjustment here. We're just going to really anisotropic map this so that we don't lose as much detail on the distance here. So what I'm going to do is we're going to change the texture import settings on green grass texture, and we're going to make it so that it has a strong, we'll just do 4x anisotropic filtering. And you'll see that made everything much sharper. And yeah, that looks just awesome. Doesn't that just look great? Anyway, thank you Unreal for writing such a cool tutorial on how to do this. They've got a lot of other cool stuff at this page. I definitely recommend checking it out. There's a lot more techniques. We may cover more later, but definitely check out their site, their page, and you can probably have some inkling now on how to start doing this yourself. So definitely give it a shot. Convert some node graphs to shaders. Get practice with it. Just start understanding that these just mean things like these just mean multiply. So this on the left side, this times this times this. That's all you're reading. This times, or this do this at that amount. That one's a little bit trickier, but we just lurked it and it was fine. So improved tiling shader. Save all. Thank you for joining us. If you have any questions, please email me, pushypixels@pushypixels.com. You can also tweet me @Dracfire. We also take suggestions for shows or what you want to see. I can't guarantee that we'll ever get to them, but if they're short, they'll probably end up on Breakfast with Unity. That's the more likely one. Longer ideas, that I have to really be into it. Anyway, thank you very much for joining us. If you can, please donate. Patreon.com/cookingwithunity. Really appreciate your support. Thank you very much, and you guys have a wonderful night or wonderful day. And I will see you tonight with more of our VogJam coverage. Thank you very much, and see you later.